passion you shared stays with me, and I pass it on. Thank you, Chris.
Yeah, you're great.
I really am getting so many of these.
It's really wonderful.
Thank you,
and you truly deserve it.
I got it out of him. Hey, you don't have to go on. It's okay. You can tell us about the night sky.
Thank you. All right. So we've got planets in the evening sky. It's just a wonderful time to look at planets in the evening sky. I saw Mars the other night. It made me joyful. It's getting so very bright. Just after sunset, we've got Jupiter looking very bright over in the east-southeast, and to its upper right, quite a ways, is yellowish Saturn, looking kind of bright. If you wait another couple hours, you'll see this really bright, not Jupiter bright, but we're getting there, reddish planet thing, which is Mars. It looks like a red star, but it's bright. And way over to it's where I was in the early evening, over to its right is Aldebaran, which is a now much dimmer reddish star, which used to be similar in brightness. So Earth and Mars are closing in on each other, and it'll be December 8th. They'll be at opposition, and it'll keep brightening until then when it's on the opposite side of the Earth from the sun. On the evening of the 20th and 21st of October, and for a few nights afterwards, there's still increased meteor activity from the Orionids, which is it's kind of an average shower, produces maybe 20 meteors per hour from a dark site. Left by debris from comet Halley. So go stare at the sky if you're patient. You'll see some meteors. And then if you live in most of Europe, do you live in most of Europe, Matt? No, you don't.
I don't even live in a small portion of Europe.
In most of Europe, southwestern Asia, and northeastern Africa on October 25th, the moon will cover part of the sun. It's normal, everyone. Don't worry. It is a partial solar eclipse. However, do not stare at the sun because it still will burn your eyes out. So find an indirect way. You can find plenty of tips on the web for watching it if that's where you are. You can get times and dates. Just search on the web.
Jupiter really is bright. You don't need to wear glasses or protection or anything like that. Have you been pointing Jupiter out to strangers? Doesn't everybody? I do.
I have in my time pointed it out to strangers. I am pointing it out right now to strangers that are listening. They're so strange because they're listening. I'm just kidding. We appreciate you, just like you all appreciate Matt. On to This Week in Space History. Mars Odyssey, working since 2001.
Wow.
Amazing. And 4 years ago, Bepi Colombo launched and is headed on its way. We're winding its way to Mercury with a couple of spacecraft, with ESA and JAXA, the Japanese Space Agency, involved. I move on to Random Space Fact.
I think you made it to fifth gear there.
Yeah, I was trying for eighth. So you may ask yourself, Matt, I know I've heard you ask, who was the first ESA astronaut to command the International Space Station? So there were a bunch of Americans and Russians. And you know who that was, Matt?
I've heard the name. I forget. Who was it?
From most of Europe, but most specifically Belgium. Frank Viscount de Win.
Yes, that is the name that I remember. Little nobility in space.
On to the trivia contest. I asked you to name the solar system body and the category of geologic feature that are officially named after abandoned cities of antiquity. How'd we do, Matt?
Just a moderate response, but some really good stuff in here. And we have a poem and a song. I'm going to start with the poem from our poet laureate, Dave Fairchild in Kansas. Apologies to anyone who may have once lived in one of these ancient cities. I traveled to Timgad and also to Angkor. Cahokia marked off my list. To Pastrum I journeyed, Caral then I hurried before they would cease to exist. These cities of ancients, abandoned on earth, our histories try to explain, and all of them named as a lengthening valleys, engraved out on Mercury's plain.
Ooh.
Very dramatic.
Yeah, I feel what is that? A sense of awe
Ah, yes, you should. So these are valleys, right? Otherwise in Latin, vallis on Mercury?
Yes, that is exactly right. That is what is named after the abandoned cities, or technically towns or settlements of antiquity that you've nicely listed off, most, if not all of them. Who is our winner?
Lisa Werner. She's a first-time winner out of Wisconsin. She said valleys on Mercury. And so congratulations, Lisa. We have a terrific prize for you. It's the CD, the just released album of the Moon Symphony from Signum Classics with liner notes, partially prepared by yours truly.
What?
And seriously, it's that marvelous performance by the London Symphony Orchestra under the baton of Marin Alsop, composed by Amanda Lee Falkenberg, who, of course, we have had on the show, and we covered that recording session. So congratulations, Lisa. We'll put that in the mail. I think it's a signed copy of the CD, signed by Marin Alsop. I got more.
Really? Cool.
A bunch of people, including Scott Borgsmiller in Maryland, longtime listener, mentioned that Vallis Cahokia, that's in Illinois, his home state of Illinois, even though he's in Maryland now. It's the Cahokia Mounds left by the indigenous peoples who lived there many, many years ago.
Yes, and in fact, I learned more about them and dug into Google Images and the like when I saw that. I was not familiar with the mounds in Illinois. Pretty cool. Maybe you can see it when you go for the next eclipse.
That'd be fun. I wonder if they're in southern Illinois. Yeah, I hadn't heard of them either. From Laura Dodd in California, another longtime listener. Dang, Bruce. I started out thinking that the name of the solar system body you were thinking of was also named for an abandoned city. What a long search through asteroids that was.
Oh, gosh. I'm sorry.
Mel Powell in California. Another regular funny guy. But Dr. Betts, how do we know that there are no abandoned cities on other solar system bodies? How do we really know? Huh?
Let's just say I'm not at liberty to tell you.
I knew it. And finally, this from Gene Lewin in the lovely state of Washington. Down in the vallis so low, we'll soon see a spacecraft, Bepi Colombo. The sun's closest planet, it is Mercury. The vallis are named for abandoned cities. There's plenty of sunshine and bright as can be. A temperature span of 900 degrees. I'd name all the cities, but the names don't quite rhyme. But all have been empty for quite a long time. Please take us to another contest.
Put your thinking caps and research fingers on ready. Although it is possible you will know this, in which case I salute you. What video game popular particularly in the 1980s owes its name to William Herschel?
Huh.
So to narrow it down, because that Herschel guy got around, popular in the 1980s and other times, but that was its heyday. Go to planetary.org/radio contest.
That is very interesting. And you have until the 26th, October 26th, at 8 a.m. Pacific time to get us this one. And, you know, we have to stick with this theme after talking to two of the great discoverers of asteroids, discoverers and trackers in our solar system. What else but a Planetary Society kick asteroid, rubber asteroid for the one who gets this one. That's it.
How very appropriate. All right, everybody, go out there, look up in the night sky, and think about a video game where the main character is Matt. Thank you, and good night. Ooh, that's, Matt, watch out. Look out.
Apparently you have played Donkey Kong. That's Bruce. He's the chief scientist of the Planetary Society who joins me, Mario, every week for What's Up.
Oh, I was debating between Donkey Kong and the Princess.
Planetary Radio is produced by the Planetary Society in Pasadena, California, and is made possible by its watchful members. There may be no better way for us non-astronomers to defend Earth than to become part of the Planetary Society.
If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM.
You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. My name is Julie, and I am joined this evening by Sana. Hi, Hi, Sana. We are broadcasting live from the Alan I. Carswell Observatory located at York University in Toronto, Ontario, Canada. This is Science Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, and then onto Western World's Quirks and Quarks and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, or that would be Tuesday morning at 2 a.m. UT. York Universe, the York Universe production works in concert with our online public viewing program run by the Observatory team, which runs between the hours of 9 and 10 p.m. local Toronto time. You can head over to observatory.info.yorku.ca and follow the links to OPV, that's online public viewing, to join the chat. Our broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. For any questions or comments you have about past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on Twitter, where our handle is York Observatory, or rather at York Observatory, or on Instagram with the handle at York U Observatory, and on Facebook at Alan I. Carswell OBS. All our programs are free, but if you would like to make a donation, we certainly won't turn you down. You can head over to our website, that's observatory.info.yorku.ca, and click on the donate button. We'll be monitoring the chat room for questions and to post content. It has been a lovely couple of days. When I was out earlier, I did notice a clear sky. So in that I'm not at the observatory, but I'm not too far from it. So I'm assuming, and Sana, maybe you can correct me if I'm wrong, that there will be live images from the telescope tonight?
I don't think there are. I'm not sure why. I'm watching one of the group chats, and it doesn't look like there is any observing happening tonight, unfortunately.
All right. Well, then there will be images from the telescope, but not live new ones, but they will be darn good images because it is a lovely telescope that takes lovely images. All right. So how are you this evening, Sana?
Oh, I'm doing very well. Like you said, we've had many clear nights. This is our 5th clear night in a row. So on Thursday, Friday, Saturday, and Sunday night, we were running observing mainly for classes. And we also got a nice stack of images on Pluto on, I think it was Saturday night. So we've had a really good few days. It's definitely been a lot of fun.
Very nice. Certainly been nice warm weather as well.
Oh,
unseasonably so.
Yeah, like this, it's like 19 degrees almost every day around here. It's perfect.
Yes, and for our friends in the States, that's 19 Celsius. So roughly double at 20 plus 32. So like low to mid 50s. For Toronto this time of year, that is unseasonably warm. Awesome. Well, glad to hear that the observatory has been so active the last few days.
And no problems with the domes, which is also something pretty new, that we can go 5 days without any, it doesn't even make any weird groaning noises or anything. So it's really fantastic.
Huzzah!
Yeah, gotta knock on wood so we don't jinx that, but.
All the wood, knocking on all the wood.
Yeah. Yeah. Well, how about you? How have you been?
I've been doing all right. Not been doing nearly that much observing. I did take advantage of the nice weather too, instead of uh, getting a ride to my daughter's robotics meeting tonight. We biked, and so on the way home, it was like, yeah, pretty sure I'd have to look it up. It was a planet. There was definitely a planet up there. I'm assuming Saturn.
Oh yeah, we've been doing some eyepiece observing for the first time in forever too, and Jupiter has been on the list every night because it's just so amazing through that telescope.
Nice. Yeah, I don't get to observe nearly as much as I'd like to, which is why I enjoyed my time at Killarney in August so much and need to go back forthwith, very soon.
Yeah, it really seems like an amazing place to go. So.
It is 10 out of 10. Would recommend. All right. Let's jump into some this week in space and astronomy history. Why don't you get us started, Sana?
Sure. So this history item is going quite far back in time, all the way to 1577, which is the anniversary of when the Great Comet of 1577 passes through perihelion. So that would be its closest approach to the sun. So unlike some names in astronomy, the Great Comet of 1577 is very descriptive. It tells you pretty much everything you need to know about it. It was a great comet that was just visible through most or all of Europe in the year 1577. And what makes this comet a great comet instead of just a normal comet is simply just because it was this visually great comet. It was huge and bright and a really visually stunning comet to be able to see in the sky. Great comets, like the Great Comet of 1577, are fairly rare, I believe, and they happen in a pretty specific set of circumstances, which is mainly when a comet passes into the inner solar system very close to the sun. So the reason that a lot of comets are pretty dim to us and we can't see them with the naked eye is just because they're very far away. So when you have solar wind and light from the sun that interacts with the nucleus of the comet, it vaporizes a lot of the stuff on the surface. So things like frozen carbon dioxide and some dust and some other stuff kicking around in there. And it makes these really big tails. So of course, the closer the comet gets to the sun, the more light, the more radiation and solar wind it interacts with, the bigger and more visually stunning the tail is. So most comets are pretty far away from the sun, but these great comets, like the Great Comet of 1577, pass so close to the sun that it just makes this really huge and bright thing appear in our skies. So the Great Comet of 1577 itself was a non-periodic comet classified with the official designation of C/1577V1, and it's had its perihelion, on October 27th, 1577. The Great Comet of 1577 was, of course, observed by, I would say everybody. Famous astronomers, including Tycho Brahe, took very detailed observations of the comet. And Tycho Brahe's observations themselves were really fantastic. So Tycho Brahe was a pretty influential astronomer. One of his students was actually Johannes Kepler, who later went on to derive the Kepler's laws of planetary motion. And Brahe himself was just kind of famous for taking these incredibly detailed observations of stars and planets, the most detailed observations that were possible without using telescopes. So he just did so many fantastic observations, which included the Great Comet of 1577 when it showed up in the sky. He did discover a couple of pretty interesting things about comets that were not known at the time. So one of the things that he did was he measured the distance to the comet. This is common knowledge now, but in 1577 it was not. Tycho Brahe measured that the comet was several times further away from the Earth than the moon. So it meant it was a phenomenon that was somewhere kind of inside our solar system, but not within the atmosphere of the Earth, not very close to the Earth. So he discovered that comets were some kind of celestial phenomenon that happens outside in our solar system. And at the time, that had been a new discovery, and it would eventually go on to become widely accepted, in part because of Tycho Brahe's observations. So his observations have actually been recently used to try and determine how far away from us the Great Comet of 1577 is. It's a non-periodic comet, so it won't be coming back to us, or I think if it does, it would be an incredibly, incredibly long time. It's not repeating like some of the other comets that we see. But it's estimated based off of Tycho Brahe's observations that it should be about 320 astronomical units away from the sun. So pretty interesting comet. I've seen some sort of sketches of what this comet would look like in the night sky, and it really did look like it was massive. So this really would have been a great sight to see if we had been around at the time.
I love looking up these like things that happened before astrophotography or photography at all, because you get these like engravings and paintings, and there's always got to be a little bit of artistic license. If you go to the Wikipedia page for the Great Comet of 1577, there's a beautiful engraving. Is the first thing there, and it's got this huge, like, the tail's massive, which I don't doubt it might have been that massive, but it's kind of cool in the sky. The sky is full of cloud.
Yeah.
Which that's not how that happens. But like in peeking through the cloud are all the constellations and like the moon and the planet. It's really cool.
Yeah. Yeah, I just pulled it up. I'm looking at it now. It is a really nice sketch. But yeah, the other interesting one I always think of is I don't remember what it was called, but it was like this meteor storm.
Yes, I want to say 1833. It's probably the one you're talking about.
Yeah, it was just the Leonid meteor shower in 1833. I think that's it. And
yeah, where it's just like that's a lot of meteors.
Oh yeah, yeah. That would have been so cool to see.
Oh yeah, absolutely.
Yeah, my only real experience with comets was Comet Neowise from a few years ago. I got a picture of it, and we couldn't see that with the naked eye from where I was, so just took a picture of it. But that was a magnificent comet, so it would have been great to see a great comet.
Nice. I always forget which one was first. I think Hale-Bopp was first, then Hyakutake in the late 90s. That was the second one that I saw. I just was still in high school. I had a paper route. I was just delivering my papers, and I spied it between the houses as I was going. So that was pretty cool.
Yeah, that sounds awesome.
And although I was around for Comet Halley in the 80s, I was only about 6 years old, and nobody thought to tell me, so I didn't look. I learned about it later and went, oh man. Then did the math and went, oh, I might still be alive when it comes back around. Maybe. Probably really old.
You gotta stick around just to see that comet.
I will do my darndest. All right. So we started with the 27th of October. We are going to move back to the 26th, but much forward in years. So we're jumping to the 26th of October, 2006, with the launch of Stereo. That is Stereo in all caps. It's not quite an acronym, because acronyms, I feel, should only use the first letter of a word. Anyways, it stands for Solar Terrestrial Relations Observatory. And It's a solar observation mission. Two identical spacecraft, Stereo A for stereo ahead and Stereo B for stereo behind, were launched into orbits that would make them pull further ahead and fall gradually behind Earth in its orbit to enable stereoscopic imaging of the sun and solar phenomena like CMEs. There's no final relative positions for these spacecraft. They just keep moving in their orbits with respect to each other, giving different views at different points in the mission. So, for example, on February 6, 2011, they were at 180 degrees from each other, and that gave a full view of the sun for the first time. So the satellites, were happily doing their thing for many years until contact was lost with Stereo B, so the one trailing behind the Earth in 2014, because it had entered into an uncontrolled spin. And they tried for 4 years because they could manage to reestablish comms for a couple hours at a time, and they tried to upload a program to fix and try to get it to stop spinning. Unfortunately, it didn't work, and after 4 years of trying to do that, they gave up. But Stereo A is still operational. So there have been numerous benefits from this mission. The first and obvious one is stereoscopic images of the sun. Also observing the far and near sides of the sun at the same time. The observations have consequences for airlines, power companies, satellite operators, other industries for which CMEs are disruptive. And so those data are relayed to those industries. Stereo has not just been used to observe the sun. It's also been used to discover 122 eclipsing binaries and to study hundreds of other variable stars. And it can look at a star for up to 20 days. So it's another example of a little satellite that was meant to last for some short number of years that it has now almost doubled or something like that.
It's really amazing that it's still in operation even when it was launched in 2006. That's really great for satellites that last that long.
Yeah. And of course when they were still the two satellites operating, there's images out there that if you have the red and cyan 3D glasses, you can see 3D sun.
Oh, that's cool.
Yeah. Stereo A was used when Betelgeuse was acting funny. Recently, they used it to observe Betelgeuse to try to figure out what was going on there. So handy little satellite, and it's just going on. It's just doing its thing.
Yeah. Yeah. I also love how the acronyms just get progressively more ridiculous over time.
Solar terrestrial relations. It makes it sound like it's a diplomat.
Yeah. Yeah, it does. Yeah. I swear for some of these, they have an acronym that they want, and they just sort of fit a name to go with that.
Yes. They refer to those as backronyms.
Acronym.
Mm-hmm.
I wonder
Make it fit.
Yeah. Yeah. Yeah, I've seen some pretty ridiculous ones. So
They make me laugh. It's endearing.
yeah, yeah, and they always work. Sometimes it's a little funny, but or really funny. But sometimes it's a little like, that's really what you want to go with? Like, are you sure?
It's my constant refrain. Because astronomers are good at naming things. It's either like a ridiculous acronym or a bunch of letters and numbers.
Yeah. Yeah, I've seen a couple where they'll try and like, sometimes even I've seen a cross between them where they'll try and work numbers into the acronym. So
Like, no, just stop. Just stop. All right. Well, our next one isn't an acronym.
no. So this is just the launch of Deep Space One. We could call it DS1 as an acronym, but I think we just stick with Deep Space. So it was October 24th, 1988, the launch of that Deep Space One satellite. So Deep Space One itself was primarily a technology demonstration and testing mission to test out new materials and new technologies for spaceflight. It flew as part of NASA's New Millennium program, which had 6 missions in total. It started with Deep Space One and operated well into the 2000s, maybe 2010, where it ended after its 6th mission. Deep Space One in particular included 12 kinds of technologies, which included a bunch of different things. So some of them were ion propulsion systems or solar power arrays to actually power and control spacecraft, and other things were more geared towards doing science, so cameras and spectrographs, and even some kind of plasma experiments. A lot of the technologies that were tested on Deep Space One were not necessarily completely new technologies. They were just sort of newer versions of some technologies that had existed, trying to make them better suited for spaceflight. So kind of lighter versions of them that didn't use as much power, all important things to be able to launch missions, keeping them as light as possible. So one of the interesting things for Deep Space One is that it was the first interplanetary spacecraft that used ion propulsion. Ion propulsion had been used on some spacecraft in the past. It wasn't really a new technology, but this was the first interplanetary spacecraft to use it. And a lot of spacecrafts now use this ion propulsion, which wasn't really something that was too common before Deep Space One. So overall, the technology demonstration aspect of Deep Space One was a very successful mission. They did run into a couple of problems with the technology, which isn't entirely surprising given how many new technologies they were using on this. And it also isn't 100% a bad thing, because you do learn a lot about technology when it does fail. So you learn how to troubleshoot and things like that. But overall, it was very successful. Some of the problems that they ran into, they were also able to fix. So some of the issues included problems with the ion propulsion failing only a couple of minutes after launch, and then failure of the star tracker instrument, which just kind of helped to point the spacecraft, make sure it was pointing in the right direction, help it, have it figure out what its orientation is, things like that. The ion propulsion issue was resolved, I think, fairly quickly. And in terms of the star tracker, they couldn't get the star tracker itself back on board, but they ended up sort of reconfiguring one of the other instruments to work as a star tracker, and reconfigured some of the attitude control to be able to work without the star tracker. So it wasn't something that completely would have ended the mission. Well, just like the stereo satellites, the Deep Space One satellite did more than simply a technology demonstration. It also included a science component to it. So the first bit of science that it did was doing a flyby of asteroid 9660 Braille in July 1999. This flyby had it at a distance of about 26 kilometers from the asteroid, which at the time was the closest a spacecraft had ever gone to an asteroid. The issue with the asteroid flyby was that some of the failures that the spacecraft had experienced earlier in the mission kind of prevented it from doing everything that scientists had wanted. It was originally supposed to go even closer to the asteroid than it did, and when it did do the flyby, some of the cameras had issues focusing, so a lot of the images that they got when it was at its closest to the asteroid were kind of blurry because the camera just wouldn't focus. But that wasn't all of the science that it did. It did get a mission extension to fly by Comet 19P Borley in September of 2001. And unlike the asteroid flyby, this comet flyby was very successful. I don't think they had any issues. If they did, none of the issues that they had were major. So the spacecraft was able to take very, very high resolution images of the comet, which were the highest resolution images of a comet at the time. And it was also able to turn on some of its instruments and study things like the way that the comet interacted with solar wind. So very, very successful science as well as technology. And on top of that, it did do a distant flyby of Mars, where it took a spectra of the red planet. So it was a very successful science mission as well as technology demonstration mission. And the last contact that NASA had with the spacecraft was in December of 2001, which was when it turned off its engines for the first time.
Wow. When you said it was a demonstration test mission, did not expect you to say, and it lasted till December of 2001.
Yeah, it lasted for quite a long time.
Oh, yeah, because I was in the 3rd grade when it launched, and I was halfway through university when it stopped.
Yeah.
So, yes.
I mean, if you have a working spacecraft with fuel, like, why not leave it on and just see what it does?
Oh, yeah, absolutely. And clearly they got to see a comet and an asteroid and some other stuff, Mars.
Mm-hmm.
Awesome.
Oh, yeah. Yeah. I always love how these missions just, so many of them just do so much more than they had planned, which is always really nice to see.
And also kind of like, it's interesting how, like if you were to ask, 100 people on the street or whatever, like, which organizations would you say has like the top technology? I'm sure NASA would come up, right?
Oh, yeah.
But like, it takes so long to get places. So like, you're saying like, oh, there were super high resolution images taken in 2001 with cameras that were built in the late 80s.
Yeah. Yeah. I know some of the instruments on JWST had been sitting on, this is going to sound bad, but kind of just sitting on the floor waiting to be installed in the spacecraft for probably about a decade before the thing launched.
Yeah, absolutely.
Even some of the new things, they just like, these are fairly old cameras that are on this amazing spacecraft and doing amazing things.
Which just leads me to ask people, do you really need the latest phone?
Yeah, that's a very good point.
Is it really going to ruin your life?
The answer is usually no.
Yeah. Awesome. All right. So we are going to go to October 30th, 2002, which is the anniversary of the date that Lance Bass did not go to space. Now you might be thinking, Julie, he didn't go to space any other day either, and you would be absolutely right. However, he did train to go to space, and he would have launched on the Soyuz TMA-1 on October 30th, 2002, if the funding hadn't fallen through. Instead, when Soyuz TMA-1 launched, cosmonaut Yuri Lonchakov was in his seat, or the seat that would have been his, along with cosmonaut Sergei Zalyotin and ESA astronaut Frank de Win of Belgium. The Soyuz TMA-1 returned to Earth on May 4th of 2003, and that's because the Soyuz get swapped out with every crew change. So the one that brings the crew up doesn't leave right away. It's the one that came up previously that leaves, so that there's not just a Soyuz sitting there that's not being used. So one comes up, sits there for 6 months, the other one gets brought down. And that was in May of 2003, its first return to Earth for this new class of Soyuz. So, when we say like, oh yes, Soyuz has been used for 40 years or whatever, it's not like it's still the exact same spacecraft as it was 40 years ago. There have been, new iterations of this one, of this spacecraft. This one apparently was more spacious with slightly more comfortable seating. Spacious being absolutely a relative term, because as far as I know, Soyuz are incredibly cramped. There was a technical malfunction on the descent that caused the control system to abandon the gentler controlled entry and descent and default back to the ballistic entry and descent. The craft landed, as a result, 300 miles short of the planned area, and the crew that was aboard that one was subjected to severe gravitational loads. They lost communications because one antenna was ripped off during the descent and 2 more didn't deploy. But the crew did regain communications after landing using an emergency transmitter, and now it is procedure to have a satellite phone in the Soyuz just in case, so that they can get in touch with the recovery crews. By the by, Lance Bass really is interested in space. It wasn't just like hey, I just happen to want to go to space. Apparently, he's wanted to go to space since he was a kid. He happens to be on the board of governors of the National Space Society, which is a nonprofit educational space advocacy organization that was founded by Werner von Braun. He's the national youth spokesperson for World Space Week. And he speaks to students about space exploration and why science and math are important. Who knew?
Man, when you said it started a ballistic entry? Kind of knew it was going to be bad.
Yeah.
From just that ballistic entry, that does not sound fun.
It's sort of the backup method. Yeah, it's not the comfy way to come back down.
Yeah, I'm glad I was not on that. A lot of the time going to space sounds fun, but ballistic entry just sounds like a nightmare.
Honestly, like I don't, for everything that I've heard about being on a Soyuz, none of it sounds comfortable.
No.
Like, no.
And then there's the SpaceX Dragon capsules that are just like, they look very comfy.
Yeah.
And even,
I mean, I'd still be afraid my body would just be like, and nope. So I wouldn't be like, me, pick me. But if I, were being forced to go into space, I would definitely choose the Dragon capsule over a Soyuz. Thank you.
The being in space part sounds fun, but the going to and coming back from space part does not sound very fun, even in like the best of circumstances. So,
I mean, I don't know, man. I get dizzy if I get up too quickly. I'm not sure that if my ears and my eyes don't agree with each other, it could just be bad.
Yeah. I also kind of freak out when someone accelerates the car too fast. So I don't think I'd do well launching into space.
No, definitely would not work. Would not work for me. I do know I have dreams of becoming an astronaut. That's okay. There are plenty of other people who do. I will let them do that.
Yep.
All right. Ooh, I like this next one you have for us.
Yeah. So this was one that I stumbled upon when I was looking through Instagram the other day. So this is technically last week, and very recent history, unlike some of the other things we have been discussing, which happened only 2 years ago, October 20th, 2022, which is the anniversary of the OSIRIS-REx tag sample collection with asteroid Bennu. And here is incoming another ridiculous acronym. So OSIRIS-REx stands for Origins, Spectral Interpretation, Resource Identification, Security, Regolith Explorer. So I definitely prefer OSIRIS-REx, so let's just go with that. And it's just kind of like, now that I'm actually reading it here, I don't think the acronym actually includes the words sample return, which it probably should, because this was a sample return mission to the near-Earth asteroid Bennu. I think I'm pronouncing that correctly. It was one of 3 of NASA's New Frontiers program, which included a couple of other notable missions, including the Juno Jupiter orbiter and the New Horizons probe, which did that flyby of Pluto, and I think is also doing a couple flybys of some other asteroids as it makes its way out of our solar system eventually. So OSIRIS-REx launched in 2016 and spent a total of 4 years traveling all the way to the near-Earth asteroid Bennu. It didn't have that far to go, which is why it only took 4 years for it to, or 2 years actually, only took 2 years for it to reach Bennu. It finally reached the asteroid in December of 2018. It was originally just put into orbit around the asteroid, which was simply because scientists didn't 100% know what to expect about this asteroid. So there hasn't been a ton of asteroid flybys or in-depth asteroid studies because they are very, very small and distant. And even if you take pictures of them with the best telescopes in existence, you still don't get to see a lot of detail on the surface. So OSIRIS-REx was put into orbit around Bennu just so it could take a bunch of images of it, learn about the shape of the asteroid, what its surface looked like, so all the more things to know about the asteroid, and also for purposes of picking a sample collection site. So after a couple years of OSIRIS-REx doing its imaging and scientists analyzing the image, they finally picked a site called Nightingale where it would do the sample collection. So this site was picked out in part because it didn't have a lot of large boulders, which there are a lot of them on the surface of Bennu. You obviously don't want the spacecraft crashing into one of those to do a sample collection because it could damage your instruments. And another good thing about this site is that it was in the middle of a crater on the surface of Bennu. The fact that it was in a crater meant the surface in that area was relatively young, so it could get a sample of rocks and dust and stuff that was in that area that hadn't been exposed to the environment for as long as the rest of the surface. It was relatively shielded for a lot of its lifetime, which just kind of meant that the sample that it would collect from the surface would be pristine. It would be more representative of the stuff that's actually in the asteroid, as opposed to, it wouldn't have been modified at all by the environment in space. So that was kind of the location that they wanted for this sample collection. So fast forward, after a couple of years in orbit around Bennu on October 20th, 2022, OSIRIS-REx executed a tag, which is called a touch-and-go sample collection. It had this arm on it with a sample collection container. What it did is it temporarily touched the surface of and immediately lifted back off again. In doing so, it sort of ejected a lot of stuff from the surface. Some of that made its way into the sample collection container, which it then closed the hatch on and stored away in preparation for returning the sample to the Earth. So this was a first for NASA. NASA had never done a touch-and-go sample collection like this. And I think it's kind of a pretty cool way to collect a sample off of an asteroid. Well, overall, the sample collection itself went very, very well. it completely filled the container full of material from this asteroid. They wanted at a minimum 60 grams of material from the surface, and it got way more than that. So kind of far exceeded the expectations of a lot of scientists in that respect. And OSIRIS-REx is now on its way back to Earth. It's going to be dropping off the sample from the asteroid Bennu, which is expected to happen in about 2023. And after it's going to kind of drop that sample off into so that the sample can make its way down to the surface, and then it's going to continue on its journey until it reaches another asteroid in 2029. It won't be doing sample return with this asteroid, but it's just going to be put into orbit around it and study it similarly to how it studied Bennu. So yeah, Canada is actually going to get about 4% of the sample from OSIRIS-REx. And this is in part due to some contributions from York University. So several Canadian scientists did work on it, which is why Canada is getting some of the sample. And one of those is Professor Mike Daly from the Lassonde Engineering Department at York. He leads up the Center for Research in Earth and Space Science, and he and his team helped develop the laser altimeter that was on OSIRIS-REx, which helped with mapping the surface of the asteroid. So very exciting for when this sample returns to Earth in 2023. Not that far away.
Yes, sometime in August. Yeah, I'm really excited for this too. The capsule holding the sample is supposed to land in Utah, and then be brought to, I can't remember where exactly, some NASA facility where they will finally find out how much they got. There was they were supposed to spin OSIRIS-REx to figure out how much they had picked up, but because of the nature of the surface of Bennu, they were expecting something a little bit more dusty, but they found something more rocky, and the collection container didn't close properly, and so if they'd done that spin, they would have lost material. And it was like, yeah, we don't need to know right now how much we have. Let's just stow that away.
Mm-hmm.
We can wait.
Yeah, if it means getting more material, it's definitely worth it.
Exactly. I'm excited to see what kind of results we get. The other Toronto connection is that one of the other Canadian scientists involved is Dr. Kim Tate from the Royal Ontario Museum, and so some of that research on the material will be done in Toronto at the museum. So that will be exciting once those results start coming in.
Are you going to get to see some of the sample?
Maybe. I was just last week down in the Earth and Space, like in their area, and I got to hold a piece of Mars, and I got to hold a piece of the moon, and it was pretty awesome. Like a big chunk of Mars too.
Yeah. Oh, that's
like a
cool.
fist-sized chunk of Mars.
Oh my god.
Yeah.
Oh, that's awesome. That's awesome.
Yeah. So I don't know. I don't know if I'll get to see some OSIRIS-REx sample return. I'm pretty sure that's going to be some pretty like tightly secured stuff.
Mm-hmm.
But you know, maybe if I ask real nicely.
Yeah.
Be like, come on, I'm a friend of York Universe. We'll see. We'll see.
Yeah.
All right. Let's go to station ID because we haven't done that in a while. You're listening to York Universe. We are broadcasting live from the Alan I. Carswell Observatory, located at York University in Toronto, Ontario, Canada. Head over to observatory.info.yorku.ca for chat, questions, content. You can find us on Twitter at YorkU Observatory, on Instagram at York Observatory, Facebook, Alan I. Carswell Obs. Tonight, you are listening to Julie and Sana. We are just wrapping up our discussions of this week in space and astronomy history. Make sure you swing by our website, observatory.info.yorku.ca, to click on online public viewing to join the chat over there. And we have a few reminders. There's a few events happening in the next week. So, Sana, I will let you take over.
Yeah. So the most exciting event, I think, that we're going to have coming up is on Monday next week. We're hosting a Haunted Herschel Halloween at the observatory. So this is kind of just a celebration of the astronomers William and Caroline Herschel. This year marks the 200th anniversary of the death of William Herschel. William and Caroline Herschel were both pretty famous astronomers who did a lot of amazing work in their field. William Herschel, in particular, discovered the planet Uranus. And another interesting thing that I didn't know about him until very recently is that he is also a musician and composer. So on the 31st, on Halloween, Monday next week, we're going to be running a joint event with the School of Arts, Media, and Design. This will include, at the start of the night, a lecture about William Herschel's life and work as a musician and as an astronomer. And we'll also include a live concert where 5 of the pieces that William Herschel composed will be played. They're all pieces on the violin, so there will be a live concert where 5 of those pieces will be played by violinists. Then following that, we're going to be running tours of the observatory, and hopefully that will include live imaging of the planet Uranus, but that is contingent on the weather, which doesn't always cooperate, so can't say 100% whether we'll be doing that, but weather permitting, we will definitely try. All of these events are free, but you do have to sign up so we know how many people are coming. There are free tickets on our Eventbrite site, just like our usual public viewing nights. And if you are not able to come to campus to see the concert, don't worry about it, because there will be a special edition of York Universe next week where we're going to be playing a recording of the entire concert. So you can hear it online if you need.
That sounds awesome. Art and science, astronomy being mashed together.
Yep.
All right, what else do you have for us?
Oh, right, yep. There is also a new image from JWST coming on Wednesday. This is going to be from their website, is highlighting a distant lensed galaxy and the intervening galaxy cluster. So if, just in case anybody didn't know, the JWST team at NASA is releasing new images from the telescope every 2 weeks at least. It seems to be more like once a week at this point. But if you want, you can check their website, blogs.nasa.gov/web. They post most of the images there. So tune in on Wednesday for some great new image from Webb.
Yeah, make sure you have like a napkin or a face cloth or something to wipe the drool off your chin.
Yeah, I got pretty awesome images from my supervisor. Works on the Canadian team that was part of the Webb telescope for the Canadian instrument. So he gets to data from 5 galaxy clusters, and I made a pretty picture out of it. And I'm
nice.
I love this telescope so much.
And there's also, in just a couple of weeks, a total lunar eclipse coming up, and this one is not at ridiculous o'clock. Totality is actually going to be between 5:15-ish and 6:45-ish in the morning of November 8th. For Toronto. I invite anybody else who is not in our general area to look it up for their own location. And sunrise is just after 7, so you should be able to, if you happen to get up that early for work, take a peek out the window while you're getting ready, or maybe get up a little earlier than you would normally. It's not one of those like I have to stay up till ridiculous o'clock in the morning or set an alarm at 2 in the morning. It's a nicely timed one.
For once.
Not that I'm complaining, really. I'm just saying. All right, let's do the news.
All right, so I'm starting us off, I guess?
Yes.
Okay, so this is something that actually happened a couple of weeks ago, but we haven't had time to talk about it on York Universe yet, so I'm bringing it up now because it's very exciting.
Go for it.
It is possibly the most powerful gamma ray burst ever observed on October 9th. So to start off quickly with what gamma ray bursts are, they're just these very, very powerful bursts of gamma rays that typically only last for a short period of time. Sometimes the burst can last even hours long, or sometimes incredibly short, like just less than a second or so. And then following that initial burst, there's a longer afterglow from the area where the burst happened, which includes radiation emitted at a bunch of different wavelengths, all the way from X-ray to radio. And these gamma ray bursts are basically just the products of the highest energy events that happen in our universe, which can be a couple of things. And those include supernovae explosions that produce neutron stars or black holes, or also neutron star mergers. So this gamma ray burst in particular is called GRB 221009A, with the numbers just being the date that it was detected, and A meaning that it was the first one detected that day. So it was detected the morning of October 9th by a bunch of different gamma ray and X-ray telescopes in space that just sort of monitor the sky in part for events like this. The burst itself lasted for about 10 minutes, so it was likely coming from a supernova explosion that created a black hole. And because it was such a high energy event, this was probably the most high energy event ever, or high energy gamma ray burst that had ever been detected. It had an energy of 18 tera electron volts, which the best way to describe that is that it is several times more energetic than the proton beams at the Large Hadron Collider. So it's sort of, I can't even think about how energetic this burst was. But because of that, astronomers have nicknamed it BOAT, brightest of all time. So,
Of course they have.
yeah, better. It's a lot better than its official name, I think.
We are good at naming things.
And on top of being the brightest of all time, this gamma ray burst is also one of the closest ones to the Earth that has ever been detected, coming from a galaxy about 2.4 billion light years away. There have been GRBs that went off closer to the Earth, but this is one of the closest, coupled with being the brightest one ever observed. So it's pretty significant. And because of all this, an opportunity like a GRB like this probably isn't gonna happen for another few centuries. So this is definitely a once in a lifetime event, and that means that a ton of observatories have pointed the telescopes at this event to take some great observations. Some of these telescopes include JWST and will include the Hubble Space Telescope as well, because it will be observed for the next several months. The gamma ray burst, just the burst itself, is only a very small part of the entire event. So they remain very interesting objects to watch over time, because you can just kind of see the way that the supernova explosion or the event or whatever it is sort of evolves over time, which gives you a lot of very important information about supernova explosions, stellar evolution, pretty much the whole thing, which is a very important thing to learn about. So definitely a super interesting object that will probably yield some very exciting results about how stars die and how they make heavy elements.
Cool. Did I lose you?
Hello?
Oh, there you are.
Yep. Very exciting.
Nice.
So 2 ridiculous names in this one. One is the ridiculous actual name, and one is the ridiculous acronym, but...
Well, the of all time seems to be the thing these days. It's very in vogue.
BOAT just sounds funny considering the gamma ray burst.
That is cool. Yeah, that is a lot of energy. Definitely looking forward to seeing what the telescopes have to add to the initial observations, especially now that JWST is involved. What will it see? What will it see?
Yeah, it took spectra of it in the near and mid infrared.
Nice. That is cool. All right. We have 5 minutes. I found a cool little story today. Scientists have found an ancient stellar catalog written by Hipparchus hidden in a medieval tome. How does this happen, you might ask? Well, paper was rare in the Middle Ages, so monks often reused old books made of parchment. Parchment is made of animal skin, and it's processed into thin, paper-like material. This takes a lot of work. It takes a long time, but it lasts a long time, too, under the right conditions, and it can also be erased by scraping the old ink off of it with a sharp knife, which is exactly what many people did throughout the early Middle Ages until paper production became common in the 1500s. So there exist a few books out there, like the Codex Climaci Rescriptus, with medieval text overwritten on much older works. And often you can see hints of the old text, but you can't read it. Until now. Enter multispectral imaging. So in multispectral imaging, you eliminate the text in different colors of light and make high-res images of the parchment. And because different inks, and even sometimes the same ink, but of different ages, reflect light differently, you can then combine the images at different wavelengths to tease out the underwriting. And then, ta-da, you can figure out what was written on the parchment before it was, quote unquote, erased. So in a recent study, a team did exactly this with the Codex Climaci Rescriptus and found the original writing contained fragments of the Hipparchus star catalog, which is thought to be the earliest detail map of the northern night sky. So Hipparchus was a Greek astronomer, and he compiled his catalog around 135 BCE. But it was lost to the ages. The only reason we even know about it is because Ptolemy mentioned it in the text of his star catalog. We now have fragments of the Hipparchus catalog. They were first found in 2017. But the more recent study found some interesting details. One of the questions that had been is whether Ptolemy had copied the Hipparchus catalog wholesale and expanded it, or if Ptolemy simply had just made reference to it while making his own measurements. The study found 4 constellations within the fragments and discovered that their star locations are slightly different from those in the Ptolemy catalog. So it looks like Ptolemy made his own catalog. And they found that the Hipparchus constellations were more precise, with positions measured to the nearest degree. And the Hipparchus was apparently a very skilled astronomer, because the accuracy of his observations wasn't equaled until Persian astronomer Ulugh Beg compiled his Zij-e-Sultani star catalog in the 1400s. So cool.
Yeah, that's awesome.
I love when, because I work in a museum, I love when history and astronomy collide.
Yep.
Throw in a mystery in there.
Yeah. That's really cool.
Yeah. All right, folks. Glad I was able to squeeze that one in before the end of the show. You have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York Universe. Your hosts this evening have been Sana and myself, Julie. Stay tuned because it's Astronomy Night in Canada. Coming up next is Quirks and Quarks, Western Worlds, and Science for the People. You can always connect with us on Twitter at York Universe. Check out our website for show notes, content updates, and contact info at observatory.info.yorku.ca. Thank you
This
for
program has been
tuning
released under
in to
Creative
York
Commons
Universe.
license.
Clear
Please contact us for
skies,
details.
and have a
You may
good
find more
night.
of our AFM original programs on our website. It's really easy to find us. We are astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.